Okay, so hello everyone. My name is Felice Sacco, and this is Universal Style Transfer on mobile devices. And my mentor is Professor Vandelovsky. Thank you. Yeah, there we go. So the goals for this internship was to take my Universal Style Transfer algorithm and put it on, pare it down a bit, so that way it runs on a regular computer like a laptop or something that doesn't have a gigantic graphics processor shoved into it. And I was able to implement the two rendering modes. It rendered images in about 30 seconds, which is pretty good. It's not as fast as the original, but hey, there's no GPU to accelerate that process, and that's what the goal was. We wanted to run the Universal Style Transfer on a phone using a TensorFlow Lite Dart implementation, and I'll explain what that is later, by testing it with the Pix2Pix algorithm that translates one kind of picture, like say an aerial shot of a college campus, into a map version of that same image. And I wanted to do that with pictures of cats for testing, because why not? And then after that, we re-implement this algorithm using Dart and Flutter. And to prepare the Flutter environment, we installed Visual Studio Code, Dart, Flutter, and their respective extensions for Visual Studio Code. Android Studio to test this on an Android device, and we have a physical device to test it with, which is a Nokia 6.1. I'm surprised that phone exists. And it launches the graphical user interface, which is awesome, and the first two buttons are able to be mapped to real Android and iOS functions, which would be get an image from the camera, and get an image from the gallery, respectively. So why Flutter and Dart? Well, it's a single code base, which means I only have to write this once, and I can port it over to 5 different operating systems and kinds of devices, which is Mac, Windows, Linux, Android, and iOS, without having to write the same thing 5 different times. So it's nice and efficient. Risks and challenges? Well, Dart front end currently doesn't want to communicate with TensorFlow Lite's C++ implementation, so we ran into, or by we I mean me, I ran into a lot of problems with that. The implementation is still not exactly identical to the old algorithm that I used in the past, in the summer. And testing on the Nokia was just as bad as the computer. It launched, but it doesn't do anything. And what did I accomplish? Well, the GUI worked. Awesome. And I flat mapped the Flutter UI buttons to the camera and the gallery, which still works. That's the only thing that really works. And at least I was able to get the TensorFlow working on Python. So at least I know that this works in theory. And we all know who this is, right? Yeah. So I ran this test on both the old algorithm that ran in JavaScript here on these styles, and I did this on the new version of the algorithm using a regular render and the inverse render, which were the 2 different versions of this program that got to run. And here they are again in more detail. So future things in Dart syntax. I have to make this TensorFlow Lite on mobile devices using Flutter and Dart actually work, and then possibly port all of TensorFlow Lite's C++ implementation into Dart, because currently the one that does exist isn't very good at it. And then maybe release the GUI under a GPL or Apache 2 license. And this is our contact information. Wonderful. And one last thing. This is our little Android simulator. It's super neat, and we can just run Flutter right here. And it launches, and that's as far as I got.